are there's this very low grade oil, crude oil-like substance called bitumen that's mixed with sand and clay and water and lots of other stuff. It exists over a large area in Alberta, like an area the size of Florida. There's also tar sands in Utah, and there's consideration of mining there. But it's happening in Alberta, and this is one of the largest mining projects ever. And so basically, to get at the tar sands, they just dig it up. They just dig up the earth. First, they have to clear cut the boreal forest, shovel off all the topsoil, because that's what the companies call overburden. It's waste, it's useless. And then they use these huge shovels to dig up the soil, put it into these 400-ton dump trucks. These things that you're looking at here are like 2 to 3 stories tall, basically like almost the size of this room, each one of them, and cart it away to these processing plants where they use, again, millions of gallons of water, a whole slew of toxic chemicals, and a lot of heat and a lot of energy to separate the bitumen out from the sand and the clay and the other stuff. Here's another processing plant. You can see that there are a bunch of ponds here as well. So there's these millions of gallons of now toxic wastewater. And some of this water is recycled, but even if it's going to be recycled, it ends up sitting in these ponds for a long time. And unlike the wastewater ponds around fracking sites, which are required to be lined with some sort of plastic or something like this, these tar sands tailings ponds in Alberta are very often not lined. And this toxic water is leaching out of them. I read a report that was estimating that in combined total, about 2.5 million gallons of this toxic water is leaching out of these tailings ponds every day into the Athabasca River here, which is also where they're pumping the water out of, and that river's being completely destroyed as a result. And these, just downstream from these sites, there are First Nations communities who have now skyrocketing cancer rates and birth defects and things of that nature. Then, once the bitumen is removed from the other gunk, it's still really thick. It's like this sticky, viscous stuff. It's not really like oil the way we normally think of it. So it's combined with some regular petroleum or some sort of natural gas diluting agent, and it's pumped through pipelines. And this is actually the biggest concern around the Great Lakes, because there's a lot of pipelines coming through this region. Pipelines existing and many more pipelines proposed. And these are, they're sending them towards refineries on the coasts. And another aspect of tar sands that is of great concern in the Great Lakes is this stuff called pet coke, which is a byproduct. It's this leftover sort of solid, crumbly gunk that is sometimes burned in coal-fired power plants. Not here in the US because it's too dirty. It has really high sulfur and heavy metal content, so it can't be burned here, but they are sending it off to places like China and India to be burned in power plants there. And there are giant piles of it sitting right next to waterways and neighborhoods in places like Chicago and Detroit. They're uncovered, they're blowing into neighborhoods, they're blowing into the water, they're making people sick. They're consistently by marginalized communities, people of color, poor people. And so we see a lot of, even though the tar sands are far away, we see a lot of effects here in this region as well. And the third one I want to talk about is sulfide metal mining. So a sulfide mineral deposit is a type of sedimentary rock that has a lot of sulfur in it, and it has metals and many other elements bonded with the sulfur. Potentially every element in the periodic table could be in a sulfide mineral deposit. But the ones that companies are mostly looking for are these valuable metals, things like gold, silver, nickel, copper, uranium, platinum, things of this nature. The sulfide mining process is similar to tar sands in a way. They just dig up a whole lot of earth, except here they're talking about solid rock. So they have to use massive amounts of explosives to blast the rock apart. Then they shovel it out, grind it up into a fine powder, and use millions of gallons of water and a whole bunch of toxic chemicals to get the metals to separate out. The return, the amount of metal that they get out of these type of mines is incredibly small. It's almost unbelievable. The average gold mine nowadays, an average gold mine takes 30 tons of rock to get 1 ounce of gold. So like a wedding band was made out of 30 tons of rock. And here's a photo of a taconite processing plant that we passed when we were in northern Minnesota. That's Lake Superior in the background there. Taconite mining is similar to sulfide mining in a way because it's also a very low grade resource. The iron is dispersed in small percentages throughout the rock. They also have to grind it up. They actually use giant magnets to get the iron to come out. It's not quite as toxic, and I'm about to get into why, but it has similar types of effects. Lots and lots of waste material, lots of polluted water, and people are familiar with taconite mining in Wisconsin and in Michigan and in Minnesota. And so they oftentimes think that sulfide mining, well, it can't be that bad. We've been doing this type of mining for decades. But the really nasty thing about sulfide mining is this, acid mine drainage. So when the sulfur is separated from the metals that it's bonded with and is exposed to air and water, it turns into sulfuric acid. And then it drains downstream, and sulfuric acid is obviously very poisonous, very damaging to almost all living things. It also has the ability to leach out metals that were inert, bonded into the rock, and totally safe, but it can pull them out. It can pull out things like lead and arsenic and uranium and cadmium and all this other toxic